Hello and welcome to a new video. This is for pre-algebra using the Math UC curriculum. We're on lesson 27 out of 30, which means we're almost all the way through the book. So that seems exciting, I think. This lesson talks about volume of cones and pyramids. And recently-ish, we did volume of prisms and cylinders, which are related actually to how we would figure out the volume of a pyramid or a cone, because the idea is that a box, a rectangular prism, or maybe like a rectangular prism that has like a square base, we could take a pyramid and we could fit it inside of that, and then we could think about the space that's not being filled up versus the space that is being filled up and say, what is the connection there? Is there some way that we can relate these two volumes? And the same thing is true for a cone. We could take a cylinder, so kind of like a can or something, and then put the cone inside. The cone has a circle for its base and then, goes up to a point. So the idea would be, is there a connection between how much space the cone is filling up in there versus how much it's not? And it turns out there is, that if we have a pyramid or a cone, it actually ends up being a third of the volume of the shape if it just continued going straight up instead of coming to a point. So we're going to see a lot of similar things to what we did with volume before. It's just that we're going to have to basically times by a third, which by the way is the same as dividing by 3. So as we look at these, our formula in general for volume that we used before was the area of the base times the height. Now we're adding to that a 1/3, but remember that this uppercase B does not just stand for base, like whenever we do the area of a triangle. It actually is talking about the area of the base. So for a pyramid that has a square base, which is what our pyramids today are going to have, a base would actually be equal to the sides squared. Because if it's a square, they're the same. So side times side would be side squared. Whereas for a cone, our base is a circle. So we have to think, okay, how do I find the area of a circle? I do pi r squared. And for pi, we're going to use 3.14, which is pi rounded because it goes on forever. But we can't really multiply forever because, that would be forever. And we have other things to do. So that's the idea. So I've got lots of examples here. For me, the most annoying thing about these is just the time it takes to actually work it out and multiply it out. For the most part, it seems like what they're giving us is pretty straightforward as far as they're giving us information on example 1 for the area of the base. This is a square because it's 7 by 7. And so we can find the area of the base by doing 7 squared, which is 49. The area of the base, that 49, is in centimeters squared. Then we're going to take that and we're going to times that by a third. And we're also going to times that by the height. Now the height is what's straight up from the base and goes up to the point. So that's going to be 6 centimeters. I don't actually like writing units whenever I go through this, but it is technically better practice to write down your units as you're going along. So just kind of keep that in mind, because then we can tell that, okay, centimeters squared times centimeters, my units for volume should end up being centimeters cubed, in the same way that x squared times x gives us x cubed. So that would be the reason to include units along the way, is to verify that we're getting the correct units at the end. So we basically need to do 1/3 times 49 times 6, or another way to think of that is 49 times 6 divided by 3, or in this one we also could say 1/3 times 6 simplifies, and then we can say, well, that simplified times 49 would give us our answer. It's not going to happen on every single problem that we can use this kind of shortcut, but if you notice that one of these two numbers is divisible by 3, you can do that first. If they're not divisible by 3, I don't think it actually makes it any shorter to do 1/3 with either of these first. So I'm going to do 1/3 times 6/1, which gives me 6/3, which is just 2. And then I'm going to do 2 times the 49. So 49 times 2, which gives me 98. So the volume of this pyramid is 98 centimeters cubed. Okay. Now let's find the volume of this cone. So the first thing we gotta do is find the area of the base. This base is a circle with a radius of 5. So we're gonna do pi, which is 3.14, times the radius squared. So 5 squared, or 5 meters squared. So the order we do this in actually matters, because we want to square the 5 and get 25. And then we want to do 3.14 times 25. So like I said, this is where we're going to end up with maybe feeling a little annoyed, because this isn't even going to end up being our answer. This is something we're going to plug in to the volume formula. We still have more work to do after this. So these can be a little bit long. So keep that in mind. Put my placeholder here. 8, 2, 6. So then add, and 2 decimals here, so 2 decimals here. 78.5 is what I get for the area of the base, this area for the circle that's on bottom. So then we want to go and put that into our volume formula. So volume equals 1/3 times the area of our base, which we just found, times our height. So neither of these are divisible by 3, so I'm going to do 78.5 times 8, and then divide it by 3. That's 64 plus 4 is 68. That's 56 plus 6 is 62. We got 1 decimal place there, so this is 628. We're going to divide by 3, and I feel like I'm running out of room. I'll divide by 3 up here. It says in the instructions to round to the nearest hundredth, and dividing by 3 very often does not divide evenly, so that means that we will have to get 3 decimal places so that we can round to 2 decimal places. So 3 goes into 6 twice. It does not go into 2 at all. So we drop down the 8. 3 goes into 28 9 times. And then actually this is going to end up being a repeating decimal, which is good because I'm running out of room here. 3 goes into 10 3 times, and we subtract 9 and get 1, and so then it just keeps being 3 over and over again. So we would look at this 3 to decide whether to round that 3 up or down, and since it's less than 5, it rounds down, so it's going to be 209.33 meters cubed. There's not really anything different about the rest of these examples. I did include a couple of examples where they give it to us in words instead of giving us a figure, but really it's all going to end up being very similar. I guess on example 3 and example 4, a difference would be that we have we have decimals to start off with, so we just have to be careful as we're doing this. So the area of the base of this, which is a square, is 3.2 times 3.2. So that'd be for placeholder, 3 times 2 is 6, and 3 times 3 is 9. So this gives us 4, 12, 10. So 10.24. We're going to take that 10.24 and put it into our formula for the area of the base. So 10.24 times our height, which is 4.1, times 1/3. Well, I'm going to go ahead and do 10.24 times 4.1 first. 1 times 4 is 4. 1 times 2 is 2. 1 times 0 is 0. 1 times 1 is 1. Put it on our placeholder. 4 times 4 is 16. 4 times 2 is 8, plus 1 is 9. 4 times 0 is 0. 4 times 1 is 4. This is 4, 8, 9, 1, 4. And there's 3 decimal places. That we're going to divide by 3, and then that will be our answer. Like I said, it may be that you're struggling with the formula and plugging things in. And in that case, like, practicing and maybe like having a parent or sibling nearby that can like double check that you're multiplying the right things together would be great. If your issue is that as you're multiplying or dividing, you keep getting it wrong, and that's frustrating, then you still basically need practice and need to be like trying to make progress with like your multiplication tables and division and stuff like that. It can be helpful to, instead of waiting till the end to check your answer, to, if you have the self-discipline to do this, to actually have a calculator nearby or have a parent or sibling nearby and say, okay, I did 3.2 times 3.2 and I got this. Is that right? And in fact, I already did this problem wrong once because I did that wrong and didn't realize until the end. So I should probably practice what I'm teaching here. So checking with the calculator on kind of each step will help you not get to the end of the problem and realize you messed up the very first thing, save you some frustration. But we are still supposed to be building our mental math skills. The better your mental math skills, the easier math is later on. So just keep that in mind. That's why I'm not necessarily saying, hey, just use a calculator and don't even worry about doing it by hand. Well, we need the mental math skills if possible. And this is a lot of practice we're getting. Okay, 3 into this once. So minus 3. 3 into 11. 3 times. 3 into 29 goes 9 times. Gonna run out of room here. 3 into 28 goes 9 times. Eek, eek, eek. 3 goes into 14 4 times. And really we don't need to keep going because we're going to use this number to decide if we round up or down. Since it's a 4, we round down. So our answer here is 13.99 yards cubed. Okay, let's look at example 4. Let's do the magma one for funsies. So our radius is 1.1. So we're going to find the area of our base, which is going to be 3.14 times 1.1 squared. So first off, 1.1 times 1.1 is the same as 121, or is the same as 11 times 11, which is 121. But then we bring our 2 decimal places in here and get 1.21. And then we need to do 1.21 times 3.14. So 4 times 1 is 4, 4 times 2 is 8, 4 times 1 is 4. Placeholder, 1 times 1 is 1, 1 times 2 is 2, 1 times 1 is 1. 2 placeholders, 3 times 1 is 3, 3 times 2 is 6, 3 times 1 is 3. And add in our columns. And there are 4 decimal places because we're looking here and here. So that gives us 3.7994. Now we could round this to the nearest hundredth place, or we could wait until later to round. And so the advantage to rounding here is that it actually makes us have to do less. The disadvantage is every time you round, you make your answer slightly farther away from what the best answer possible is. This would round to 3.80. We're going to put this into our volume formula. The area of the base is 3.80 times 1/3 times the height. So we're going to do 3.8 times 5.5 and then divide that by 3. So that's 40, 19, 40, 19. That's very nice. So I get 2090 with 2 decimal places. Now let's take that and divide it by 3. So 3 goes into 26 times. And 3 goes into 29 9 times. This happened to us a lot here. And then 3 goes into 26 times. And then we actually need to do one more so we can round. That'll be 6 again. So this actually rounds up to 6.97 meters cubed. Okay, so for these last two that we have, we're going to we could draw a picture ourselves. That's an option. Or we could just say, I can probably fill in the formula myself without having to draw it. It's up to you. But if you're like, man, I don't know, I'm not sure how to do this, then drawing a picture is an idea. I guess the issue here, though, with drawing a picture is that, like, you know, it's hard to draw a picture of these. it took me a bit of effort to draw the pictures I drew on here. So keep that in mind. So example 5 is talking about a pyramid. It's saying the base is a square with sides that measure 3 inches. The altitude of the pyramid is 8 inches. This word altitude is similar to the word height. That if you think about altitude, like when you're in an airplane, that's how far you are above the ground. So that's the idea of altitude, is it's also like that. It's the height. Oh, I should have made one of these, like, what's the volume of a pyramid in Egypt? But I didn't think of that, so maybe next time. The area of the base is going to be 3 times 3, which is 9, or 3 squared. And then we're going to put that into our volume formula. So that's 9 times 8 times a third. So this is another case where we actually could do these two first. 1/3 times 9 simplifies to be 3. And then that's helpful because 3 times 8 is 24. And we didn't have to do long division, which is nice. So this pyramid, the volume of it is 24 inches cubed. How about this example 6? What's the volume of a cone with a diameter of 10 feet and a height of 4 feet? Now, I tried to trick you. Did it work? We got the diameter, but our formula needs the radius. So we have to half our diameter to get that our radius is 5 feet. So the area for the base of this cone is going to be 3.14 times 5 squared, which we did earlier. So how convenient. That was 78.5. And then the height wasn't 4, was it? Because that'd be convenient. No, it was 8. So actually, we could be crafty here if we wanted to. So volume is 1/3 times 78.5 times 4. So I'm going to do 78.5 times 4, and then I'm going to divide by 3. So this is 20. 32 plus 2 is 34. 28 plus 3 is 31. 1 decimal place, so 314. We're going to divide that by 3. So it goes in once. Whoa. 3 goes into 1 no times. 3 goes into 14 4 times. 3 goes into 26 times, and then that is going to just repeat. So this rounds up to 104.67 feet cubed. Thanks so much for watching. I hope you enjoyed this video. We only have 3 more lessons left in this Math UC curriculum, but I also have a few things in mind that I think would be helpful to look at before you end up going into Algebra 1, so I'll post those as well. If you liked the video, please give me a thumbs up. If you aren't already subscribed, you can do that too, and I'll see you in the next video. Thanks.